Hello students, this is our last point of binding energy. Not the escape velocity is last point, the binding energy is the last point. So what is the binding energy? The minimum energy required by a satellite to escape from Earth's gravitational influence is called the binding energy of the satellite. So consider a satellite of mass m revolving at height h above the surface of the earth in a circular orbit. M with the mass of the earth, R is the radius of the earth, E is VC with the critical velocity of satellite, and small r is equal to capital R plus h be the radius of the above the orbit. So that is kinetic energy of satellite is equal to half mvc square. So half gmm upon r, putting the value of critical velocity. Okay, because the critical velocity is equal to root of gm upon r. So vc square, we are taking square root, we get half gm upon r. And the gravitational potential at a distance r from the center of the earth is minus gm upon r. So therefore potential energy of satellite is equal to gm, put gravitational potential into mass of satellite. So mass of satellite is denoted by small m, and gravitational potential means minus gm upon r. So total energy of the satellite is given as total energy is equal to kinetic energy plus potential energy. So therefore kinetic energy means half gmm upon r minus gmm upon r, which is the potential energy. So therefore minus 1/2 gmm upon r. So a negative sign indicates that the satellite is bound to the earth. So due to gravitational force of attraction, for the satellite to be free from the earth's gravitational influence, then its total energy should become non-negative, means zero or positive any. So hence the minimum energy of the supply unbound satellite is plus half gmm upon r. This is the binding energy of a satellite. So now here our chapter is closed now. So gravitational chapter is completed. Now let us see some examples, means numericals or problems on this chapter. So let us see first example. At what distance below the surface of the earth the acceleration due to gravity decreases by 10% of its value at the surface? Given radius of earth is 6,400 km. Okay, now solve this. First write down given quantities. So here given quantities are, so first find out what we find out. So here find out at what distance below the earth, the surface of the earth. Okay, so what distance below the earth surface means we find out here depth, and given quantities is the small gd, acceleration due to gravity, is exactly equal to decrease by 10, gravity decrease by 10%. So 10% means now here is 90% divided by 100 into g. So 90 upon 100, and r is the 6400 km. So 6 rearrange the equation. So rearranging kilometer means 10 raised to 3. So here 2 zeros, then we get it 10 raised to 2. So 10 raised to 2 plus 10 raised to 3, we get 10 raised to 5. So we get here total radius of the earth is 64 into 10 raised to 5 meter. So again here using equation is gd is equal to g in bracket of 1 minus d upon r. So gd means the 90 upon 100 into g. So it's exactly equal to g 1 minus d upon r. So 90, 0, 0 cancel out, so we get here 9 upon 10, and here g is here, then here numerator, then denominator also we get here g, so g cancel out, we get here 1 minus d upon r. So rearranging this equation for d upon r, so is equal to 1 minus 9 upon 10. So d upon r is equal to, when multiplying 10 minus 9 upon 10, so we get a 1 by 10. So d is equal to r upon 10. So r means we know that 6 4 into 10 raised to 5 upon 10. So we get here 6 4 into 10 raised to 5 into 10 raised to minus 1. So there 10 means 10 raised to minus 1. So we get here 5 minus 1, we get 4 plus 4 meter. So therefore 640 into 10 raised to 3 meter is nothing but 10 raised to 4 means 10 raised to 3 conversion. So we get here 10 raised to 3 means kilometer. So final value we get d is equal to 640 kilometer. So now our next numerical is, if the earth were made up of wood, the mass of wooden earth would have been 10% as much as it is now, without change in diameter. Okay, so calculate escape speed from the surface of the earth. So write down here given quantities first. So V is equal to, so here given quantities present mass means capital M, and wooden earth M dash is equal to 10 upon 100 into M. So escape speed of from wooden earth, so V is equal to root of 2 gm upon r. So this constant value we know that 11.2 km per second. And now V dash for the escape for the, so we get here V dash is equal to root of 2g 10m upon 100 r, 100 into r, because wooden earth mass m dash is a 10 upon 10 m, means mass of wooden earth is been 10% as much as it is now. So we get here 10 upon 100. Okay, so solving this equation we get V dash is equal to 3.54 km per second. So use your log table, or we doing here multiplication. Anyway, we find out the value of V dash is equal to 3.54 km per second. Okay, now next numerical. Next numerical is, calculate the value of acceleration due to gravity on the surface of Mars. If the radius of Mars is equal to 3.4 into 10 raised to 3 km and its mass is 6.4 into 10 raised to 23 kg. So we know that the planet is Mars. So is the radius of the mass is 3.4 into 10 raised to 3 km and mass is 6.4 into 10 raised to 23 kg. We will find out. So write down first given quantities. Here we find out the value of acceleration due to gravity. So means g of Mars planet. So g mass we find out now. So we know that the r mass means 3.4 into 10 raised to 3 kilometers. So 3.4 into 10 raised to 6 kilometer, because k means 10 raised to 3. So 10 raised to 3 plus 10 raised to only 3, we get here 10 raised to 6 meter. So therefore mass of the Mars is equal to 6.4 into 10 raised to 23 kg. So we know the formula for acceleration due to gravity, G is equal to gm upon r square. So putting all these values in this equation means here 6.67 into 10 raised to minus 11 into 6.4 into 10 raised to 23 upon 3.4 into square into 10 raised to 12. So G is equal to 6.67 into 10 raised to 11 minus 11 into 6.4 into 10 raised to 23 upon 3.4 square into 10 raised to 12. So first find solving this 10 raised to power, and we get here 10 raised to minus 11 into 10 raised to minus 12. This is the denominator, we put up on numerator, so we get here inverse with minus sign, and then here 10 raised to 23. So 10 raised to minus 11 plus 10 raised to minus 12, we get 10 raised to 20 minus 23. So 10 raised to minus 23 into 10 raised to 23 cancel out. So we get here 6.67 into 6.4 upon 3.4 into 3.4, because here square. So solving mathematically or using log table, we get G is equal to 3.69 meter per second square. So here our chapter is closed.